Hello, people. Okay, so you're going to see your lesson on electricity, and then you're going to see this video that kind of demonstrates some of those things that you learned. Right? So this is our training board. At the top here is DC voltage, 12 volts DC. Over here is 5 volts DC. And over here is 12 volts AC. Okay, if you remember, we were talking about both of those types of currents. This point here is ground. If you look inside the board, you can see it's wired all the way back up. So this ground and this ground are connected, and this is 12 volts. On this side is a switch, and you'll see the LED light up here turn on when I turn it on. So one of the first things that we talked about was volts, amps, and ohms. So let's look at those for a second. But first I want to show you our meter. Okay, so this is a Fluke 87, and we have some stuff going on here. So here is volts AC. If I go like this is volts DC. Notice the symbol with the sine wave versus the dashed on and off, because DC voltage is on or off. We have millivolts DC, which is really small volts. We have ohms, and this symbol, it stands for continuity, which means almost zero resistance. This is for checking diodes, which you won't do yet. This is AC amps and milliamps. This is microamps. Notice all these yellow things. That's like a shift button. So when we press it, for this one, it gives us whatever that is. If I do this one, that gives us temperature. If I do this one and hit it, that gives us the ability to check capacitors. If I do this one over here, that gives us DC instead of AC, and the same thing here. So we can use that to do stuff. A couple other things that we have here is we have the ability for continuity. This will make a sound anytime resistance is almost zero, and I'll show it to you. Min-max lets us do like a recording. Range lets us move the decimal point in the display. So if I go like this, for example, volts DC, and I hit range, you'll see the decimal place move. All right, so that lets us get the display to be able to show whatever it is that we want to do. Over here we have a light. Okay. So let's start looking at some stuff. So the first thing I want to show you is DC voltage. If I take, remember when we talked about voltage drop, got to get this on the camera. These two leads are connected here, right? So here's your red, and here's your black. So remember, anytime we're using a voltmeter, we're taking a difference of both of these leads, whatever the difference is between them. So if I turn this on, and I put this in ground, when I touch this to a different voltage, we should get a reading, right? So if I put it to ground, obviously it's zero. There's no difference there. But if I put it here, I got to hit the range so it'll display it for you. 12 volts, 12.8 volts. So that means there's 12.8 volts coming out of here, 0 volts there, and the difference is 12 volts, and that's why this shows it. If I put it in this one, 5 volts. That's the difference between those two, 5 volts. Okay, so now as we do things, we're going to apply voltage from the top, and we're going to ground it at the bottom. So here we have, we'll take this one. The light bulb, two sides of the filament. Put it in there. We bring power into it. We supply ground. Right? The light lights. Very bright. I'm not sure how it looks on camera. If we check voltage now, whoop, I disconnected. Whoop, right, 1150 something. $11.60 something. 0. Right on the other side. Right? So 12 volts here. Zero volts there. Therefore, the rule that says as voltage goes through a resistance, we have a decrease in voltage. This light bulb used up the voltage that was going through. If we have no change in voltage on both sides, watch what happens. So we connect this to ground. 12 volts. 12 volts. 12 volts on the end of the wire. 12 volts. Both sides have 12 volts on it. If both sides have 12 volts on it, no electrons flow. Because no electrons flow, Mr. Light Bulb doesn't turn on. Okay? Now we can look at this. We have electrons flowing through this light bulb. How can we see it? Well, we can take our meter, we turn it off. We have ports on the bottom: amps, milliamps, common, volts, ohms, temperature, diodes. Right? We just measured volts. I'm going to move this over to here. You're going to get another lesson on this, but this is how we're going to do it today so you can get it. And we're going to move it to amps. Right? We never go with milliamps unless we have a reason to, and we'll explain that when we go further. I'm going to hit the yellow button, and now it gives us DC instead of AC. To measure volts, the circuit stays in place, and we measure it from the outside. That's called hooking the meter up in parallel, because we do not disturb the system to measure it. We just jump in and we create another branch, and when we talk about using a meter, we'll talk about that deeper. For measuring amperage, we have to bring the current through the meter so the meter can get it. The meter is protected to 10 amps maximum. So if we were to measure something that was more than 10 amps of rating, we would hurt the meter. If we hurt the meter, a fuse blows inside that costs about $17. What we're going to do is, if we know we're well below 10 amps, we can run it through the meter. If we can't, we have to use what's called an inductive pickup, where we wrap it around the wire and we pick up the magnetic field of that wire, and we can get an accurate reading. Right? So here, we will break the circuit, and we can do it here, we can do it here, we can do it up top. It really doesn't matter where. And we're going to hook in line. The red lead goes to the most positive side, which is up here. The black lead goes to the most negative, and this is the most negative. So we'll put it here, and our light bulb lights, and we can see 1.9495 amps DC. Now, do you remember when I said in the other video, draw 6, 2, 5, and 16 zeros? That's how many electrons go through a given point in 1 second. That's for 1 amp. And this is almost 2 amps, which means twice as many. Okay, so there's the amperage. That's the electrons that are flowing. Now, the electrons, by electron theory, had to move up from the ground, across the load, up to that point. As soon as it touched the positive plate, current races back down the other way. Okay, so now you had volts and you had ohms. So now let's look at resistance. So this meter has ohms in the middle. It beeps at you, it's telling you lead because this has to be put into its proper position. If we touch these together, we see ohms, we're basically 0 ohms. And our leads are touching each other. That 0.1 is the resistance in the wires themselves. Okay, so if we check a resistor, okay, nothing exciting going on with it, it's just a resistor, but it's got a value to it. So now we measure across it. And we can see 99.5 ohms. Right? That's how much resistance is going through there. I don't know if you could see that red light on top. Yeah, I think you can. Here's ground, 0 volts, and here's power, 12 volts. If I touch them together, watch what happens. The circuit breaker inside shorts because the